Everybody's ready.
They have all these blackout days because at Landis now you can use points.
Right. That was the other thing, is to use those points would be the way to go
That would be
too.
the way to go. But
That's what I did. I paid for the flight and then we used points for the hotel.
But apparently everything's blacking out. I mean, because of the holidays. And so it's tricky because it's and more available during the actual holiday, but it doesn't necessarily, so that's the.
We went through that too, and Molly was like, "We have to get home for Christmas," and I was like, "No, we don't."
Yes.
And she said, "Yes, we do." Now I think she knows that it's okay, and that Santa would find us wherever we may be.
Right.
And she's not so worried about it, but
I went one. Where did we go? Oh, we went locally 1 year, but it was further away. It was in Pennsylvania, and I remember Santa found the kids, but it was like,
yes, it's a big deal, right? All right, let's clear our writing pads there. And what are we're gonna do some math today. You guys ready to do some math?
Yes. Yes.
Yes. All right. Let me see where your squared charts are. Just gonna have us warm up by doing our perfect squares chart. You all remember our perfect squares?
Yeah.
All right, so what we're going to do is we're going to say our square numbers. So 1 squared equals 1. 2 squared equals,
4.
say it, we're going to do it together. Remember, I need you all to respond, both of you to respond at the same time. So 1 squared is
1.
2 squared is
4.
3 squared is
9.
4 squared is
16.
5 squared is
25.
6 squared is,
30. 36.
let's try that again. 6 squared is,
36.
7 squared is,
49.
8 squared is,
64.
9 squared is,
81.
10 squared is,
100.
11 squared is,
121.
and 12 squared.
144.
Okay, so when we square a number, we have the exponent of
2.
2. So we've got our squared numbers, and you see the pattern. What's this? What direction is this? It's a diagonal, right? So our squared numbers always form a diagonal on our multiplication chart, right? So we always can find our squared numbers, okay? Remember when we colored our squared numbers, we went like that?
Yes.
Yep, to show that that's how many cubes it takes to fill in that
Yeah.
square. It makes a perfect what, Molly?
Square.
Good, okay. So let's see. So we've practiced our perfect squares. Let's see. Let's do a little practice and review on our board. If I asked you all to draw me 1/2, can you draw me 1/2 on your boards?
Like as a picture?
Has a picture. Draw me 1/2.
No.
Okay. Now can you draw me another picture? I want to see 1/2 of 1/2.
1.
Molly wasn't here that day we redid this, Sarah. So you might have to show her. So there's 1/2, and then Sarah is doing 1/2 of her 1/2. So draw 1/2, Molly. It can be in a circle or a square. It doesn't matter. Sarah chose to use a square.
It looks like a window.
Okay, great. And another way to do it would be if I just said draw me 1/2. There's my 1/2 of a circle, right? And then I can kind of fill in the other half like with a dotted line. Do you see that? That's 1/2. And then if I said give me 1/2 of my half, Molly, I'm just doing that.
Okay.
Okay? What about if I said show me 1/3 of 1/2?
1.
I'm going to get you guys a paper towel because those erasers are going to get messy. I like those markers you got those. Sarah, those new markers?
Mm-hmm.
That's good, new markers for the whiteboard.
Bye, guys.
Where
Bye.
are you going?
I have to go, remember I have to go do all those things for Sophie's school?
Oh, are you coming back?
Yeah.
Thank you.
I hope so.
Here's a paper towel, sweetie.
Thank you.
Okay. So, wait a minute, Mal. First, just draw. Oh, you draw. I want you to draw me the one half, and then draw one. So you've got. There you go, Sarah. Good. So what do you have? One of 3 equal parts, right? Nice. Can you show it to me in a circle?
Me?
Mm-hmm. When we do a circle,
wait. Oh!
right? Try again. Use the paper towel, sweetie pie.
No, but that's gonna get.
Just erase the whole thing. Start over. Good. Nice. Molly, can you tell me what you have drawn there? You have 1 half.
I think just forget about that. The white is the one that I didn't do.
Okay. So then that would be 2 of 3 equal parts that you had there.
No, it's one because okay, we get it.
Okay, you need to show me. So I want Molly to draw me 1/4 of 1 half. So first draw me a half, Molly. Just the half of the circle. And then do the dots like I showed you. Okay, so you've got 1 half there. And now I'm going to ask for 1/4 of that. So imagine if you were to put this into force. Can you give me 1/4? Color in 1/4. Good. Well, each half you would break into
2.
2. Good. Nice. Where's yours?
Oh.
Could you draw one for me too?
Mm-hmm.
Does that make it a little easier to see? Are you sure?
Mm-hmm.
Okay.
Like that.
Yep. Good. Good, good, good. So Molly, we can go back and redo that. I don't think you were here the day we did that one.
No.
When we were drawing, when we got out and we're drawing our parts, our fractional parts. So we can definitely review that again. All right, let's put our pens down and let's do a little bit, some mental work and some verbal work. Remember when we were doing, now Molly, I think you were here, right? When we did 2.5 times 10?
Yes.
Okay, so let's do 2.5 times 10. So 2 times 10 is
20.
20. Let's hold it in our working memory. Let me hear it. 20, 20, 20. And plus half of 10 is 25. 2.5 times 10 equals
25.
2.5 times 10 equals 25. All right, so let's do 2.5 times 20. 2 times 20 is
40.
hold it in our working memory.
40.
Half of 20 is
10.
40 plus 10.
50.
2.5 times 20 equals
50.
good job. All right, we're going to take it up a notch. 2.5 times 100. 2.5 times 100. 2 times 100 is
200.
half of 100 is
50. 250.
250. 2.5 times 200.
250.
You just said 2. Nope. You did 2.5 times 100 was 250. You got that right. Now we're going to 2.5 times 200. 2.5 times 200. 2 times 200 equals
400.
hold it in our working memory. 400, 400, 400. Half of 200 is
100.
400 plus 100 equals
500.
2.5 times 200 equals
500.
500. 500. 2.5 times 200 equals
500.
500. Good. All right, let's take it up one more notch. 2.5 times 2,000. 2 times 2,000.
It's 4,000.
Hold it in our working memory. 4,000, 4,000, 4,000. Half of 2,000.
Half of 2,000 is 1,000.
4,000 plus 1,000 is
5,000.
2.5 times 2,000 equals 5,000. Good job, ladies. Good. All right, so we have reviewed a bunch of different things, and we did our vertical number line where we actually used our toilet paper roll. I don't have one handy to show you, but remember we use that and we practice our positive and negative numbers. God bless you.
Thank you.
And what can you tell me about 0, Sarah?
It's not negative or positive.
It's not negative or positive. And when something is below 0, it is what, Molly?
Negative.
And usually when we're in the red, we are in the negative. And we're in the black, we are
In the
In the
positive.
positive.
in the
Positive.
positive. That's right. And we are moving above the 0. So we want to remember that. And last week we played a card game with our red numbers and our black numbers, and we did our positive and negatives. So we're going to play another game with positive and negatives, but I want us to read it as we see it and write it as we read it, okay? So, but we're going to use these dot cards today. So I made these dot cards for us to use, and I didn't have any black dots. So green is going to be our positive. Does that make sense? Because green equals money, right? Money in the bank. So it's positive. And this is kind of an orangey red, but we're going to use this as our
Negative.
negative. Okay?
So we do multiplication and addition.
I think we should do multiplication and division. Is that what you guys want to do? Should we review some positive and negative first? Let's review some positive and negative first because I want to make sure you guys have it. Okay? So what I'm going to do is we're going to put the cards down and we're going to, what's the rule with positive and negative? Do you guys remember what we talked about?
Like the rule for multiplication and division.
Sure, tell me that one.
If the signs are the same, you simply
No. When are we multiplying or do we?
multiplying. Okay, when the signs are the same, it's positive, and when the signs are different, it's negative.
When we're multiplying positive numbers and when we're multiplying integers, let's say, because integers mean they're going to be positive and negative. So when we're multiplying integers, if the signs are the same, then your answer is always
Positive.
when you're multiplying integers and your signs are different, your answer always is
A negative.
a negative. Good. All right, so we can always use our little, what my teacher calls this is a near point reference. So we keep it here in case we need it. We can look at it. And I put one down on an index card for us too.
Cool.
Okay, so when we're multiplying or dividing, when we have 2 positives, we get, when we have 2 negatives, we get,
Positive.
and on the other side, I have when the signs are different and we're multiplying and dividing, we get,
A negative.
when they're different,
Negative.
negative. Okay? So I made us a card as a near point reference too. Okay? And then I also made a card for adding and subtracting. So we're going to start with that one. Okay? So let's add 1 up. Oh, wait, we're going to read it as we see it.
Negative 1 minus positive 1. Plus negative.
Is it plus?
So what is this?
Negative 1
Negative 1 plus 1.
positive 1.
Just plus 1. Read it as you see it. Write it as you see it. Negative 1 plus 1. And it equals?
0.
Good job. Good job. Because why? A number
and its opposite is always 0.
A number and its opposite is always 0. Good job. What if I were to do this? -1 plus 2 equals? Good. All right, here's another one. This one is 3 minus 2. I didn't say that.
But you said this was always negative.
You've created a different type of problem. There you go. You got it, sir. You could say 3 plus -2.
What did I say?
3 minus negative.
You said 3 minus -2. When we have signs that are different in adding or subtracting, what do we say? Which number is bigger? The sign goes with that, and then we simply subtract. You had it right, Mom. Okay, ready for another one?
No. Yes.
Yes? No?
Yes.
All right, what about that one?
4 plus -2.
Nice. Nice. Good verbalizing. I'm going to do that one, but I'm going to just flip it. So now we write -2 plus 4. Molly is correct. Oh, why did you put a negative there?
Because this 4 is bigger.
4 is bigger, so there's no negative with 4, is there? Good, good. All right, so let's do just a few more so I know that you guys are feeling really good. Are you feeling good about this? Molly was feeling a little sad at first, but now I think she's back on. Let's see. How about that one? Good. If I were to flip it, do you see how the order changes everything there? And those signs are really important, aren't they? Good. Look, Molly. 3, -3. Erase the whole thing, honey. -3 plus 6. There you go. Okay. All right. So we remember our adding and subtracting of positive and negative numbers. And it does get a little confusing. But when we go to multiplying, we're going to have a similar thing, but the rules change again, right?
Yeah.
All right. So right now, what do I have here? If I put a big multiplication sign in the middle,
3 times 1.
what kind of 3 do I have?
Negative.
-3 times -1. What is it?
Positive 3.
Good. All right, what about when I do that? Now I have -3 times +1.
Equals -3.
Good, good. And now I have 2 times 1. Good. All right. Does it matter so much the order when you're multiplying and dividing?
No.
Not so much when you have the not like it does when you're adding and subtracting, right? +2 times -4 equals.
-8.
And if I did this, if I did -4 times +2, would my answer still be -8?
Yes.
Yes.
It is. So in multiplying with integers, the rules change a little bit, right? Because it says it doesn't matter how they're ordered, The answer remains the same, okay? So that's an important concept for us to get to know. The other thing I was thinking about too, what did I want to show you? Well, we'll keep going while I remember where I wanted to go. A negative 4 times a negative 2. We should put our negative part out. Good. Awesome. I think you guys are really... Now, could we do something, if I were to say, what number does this give me?
42.
42. So we could use these cards to actually do bigger numbers because we could use them as our tens, a ones place and a tens place, right? We could probably even do, how many place values do we have here? Ones, tens, hundreds. Okay? So we could use these to make bigger numbers. So that's what I want us to do. Let's say negative 22 times positive 3. Now, let's think about this. What are we gonna do with that 22? We're gonna break it up. What is 22 made of?
Two tens.
Two tens. So it's going to be 20 plus 2, right?
Yeah.
So 20 plus 2. And so the way we would write that, 2, is what happened to my marker? Okay. So another way we could write that would be, this is the distributive property. We started talking a little bit about this in one of your homeworks. And what's our sign going to be? Negative, right? So do you see that we blew up that? So then we do the 3 times 20?
60.
60. And then the 3 times 2?
6.
66. And it's a negative, right? Don't forget. So that's why we always do our sign first. So do you see how we do this distributive property, Sarah?
Yeah.
You see that? Okay, let's try another one. I'm going to keep the numbers low in the beginning so we make sure we know what we're doing. Let's do 32 and let's times it by negative 32 times a positive 4. So let's blow up that. Good. Blow up that 30. Good. Put your sign down, Mo. What's your sign? Negative. Good. 4 times 3 is 12 with the 0. Add your 0 from the 30. Good. And then 4 times 2 is 8. So just 128. You were right. I saw what you were doing. Sorry, hon. Negative 128. Good. Good, good. Is this making sense?
Yes.
Okay. Shall we try and make it a little harder and maybe make it 134 times a negative 2?
Oh, it's negative?
Yeah, negative and negative. Yep,
Oh.
sorry, negative and a negative. So put your sign down before you blow them up. So it's made up of, Sarah, what's it made up of?
100 plus 30 plus 4.
So 100 times 2 is 200. We could probably hold it in our working memory. 200, 200, 200. 2 times 30 is 60. And 2 times 4 is 8. So we've got 268. And are we a positive or are we a negative?
Positive.
Good. Do you see how easy that makes your multiplication of these big numbers?
Mhm.
Right? How are you feeling about that?
Good.
You feeling good about that? All right. So this went faster than I expected, ladies. Last week we had such issues. I thought we were going to take a lot longer doing this. So I bought us some cards, blank cards, and you guys can make your own set of positive and negative numbers if you want. We can do that. Or I can see what else I have in my repertoire and we can move on to another new concept. What would you like to do? You want to make some cards?
Yes.
Okay, all right. You guys can make some cards. I want you all to use the patterns, right? You're going to use your patterns. What is this a pattern of?
5.
Right? So these are our dice patterns, right? 1, the 3 goes down. What is this going down? What's this called?
Diagonal.
Good. And our 4 looks like that. And our 2 goes in the,
Diagonal.
right? Our 5 looks like that. And our 6 looks
Look
like
that.
that. Like a dice. Like a die, rather, right?
Do you need any colored, like markers?
I think that you guys can use the stickers, just like I did, and make your sets
Okay.
of cards, okay?
Okay.
And then you can
What can
practice
I
them.
put in?
I'll take these back, all right? And then you can practice them.
So this is positive.
Green is positive because it's money in the bank. And the orange is kind of reddish, so it's money out of the bank. All right, girls, I'm signing off on the video here.